This is a problem involving work and the work energy theorem from 1977 here. It says a block of mass 4 kilograms, which has an initial speed of 6 meters per second at time t equals 0, slides on a horizontal surface. Calculate the work, W, that must be done on the block to bring it to rest. So, if you're talking about something that's moving and doing work on it at the same time, then you're going to be talking about the work energy theorem, which says the work you do is equal to the change in kinetic energy of that object. So now, remember, change in kinetic energy really means that the final minus the initial. There is no final if we bring it to a rest. In other words, if we got some initial kinetic energy, then the work we got to do is equal to that initial kinetic energy. Negative, though, because we got to take that energy away there. So let's set that up then. The work is simply equal to the initial kinetic energy, negative, and so that's 1/2 mass times initial velocity squared. So when we plug everything in, the mass is 4, the velocity is 6, don't forget to square it. Half of that will be 2, and then 6 squared would be 36, so 2 times 36 is 72, negative 72 joules, because we've got to take it away there. Part B says if a constant friction force of magnitude 8 newtons is exerted on the block by the surface, determine the following. The speed of the block is a function of time t. What these mean is, this is sort of an older way of phrasing it, but it's got to be some equation where it says V equals, and then on the right side, it's got t in it. So I know of an equation, it's the first one, first kinematic, that's got t in it there. So the velocity at any given time is the initial velocity plus acceleration times time. There is no initial velocity though, so that drops out. But now let's replace A here. So A we know is equal to F over M. So anytime we can actually put a number in here as opposed to a letter, we want to do that. Our force, remember, is 8 newtons, and our mass, they said, is 4 kilograms. So our acceleration there is going to be 2 meters per second squared. So now let's fix this one right here then. Our velocity will be equal to an acceleration of 2 meters per second squared times t. So we can figure out the velocity at any given time now by simply taking that time multiplied by 2 there. Last part says find the distance that the block slides as it comes to a rest. So now we already figured out, remember, how much work we did. We did negative 72 joules of work. But work also means something else. It is force times distance times the cosine of the angle between the two. We know how much force there is, they already told us that. The angle, by the way, let's just pretend it's sliding to the right, then the force of friction would be back to the left. So this angle is going to be 180, which is going to give us a -1. So negative 72 joules here is equal to our force of 8 newtons times distance, which we're looking for, times cosine of 180 degrees, which just give us a -1. So 72 divided by 8, which is 9. So this thing will slide 9 meters.